Question 12, Part E. The diagram shows the graph of a function f of x. The equation f of x equals 0 has a root at x equals alpha. The value x1, as shown in the diagram, is chosen as a first approximation of alpha. A second approximation, x2 of alpha, is obtained by applying Newton's method once, using x1 as the first approximation. Using a diagram or otherwise, explain why x1 is a closer approximation of alpha than x2. This is best explained with the help of a diagram. I've recreated a sketch of the graph of y equals f of x from the question. Here is the root alpha that we're trying to approximate. Here is x1, which is our first approximation to alpha after one application of Newton's method. I've defined a point A on the curve that is directly above x1, which has coordinates x1, f of x1. Now, Newton's method involves finding the equation of the tangent to the curve at point A and then noting the x-intercept of that tangent. Ideally, the x-intercept of that tangent should be closer to the root that we're trying to approximate, not further away. And in this case, we can see that x2, which is our second approximation, is further to the right of alpha compared to x1. So the approximation is actually worse. And I've noted it here. The tangent to the curve y equals f of x at point A, where x equals x1, has an x-intercept x2, which is further to the right of alpha compared to x1. Hence, x1 is a closer approximation of alpha than x2.